Hi friends, in this video we are going to discuss about LCR circuit when it is subjected to alternating voltage. Consider this circuit where you have a resistor R and a capacitor C and an inductor L, say, of inductance L and resistance R and capacitance C. Let the external voltage be Vm sin omega t as usual. Now, by Kirchhoff's loop law, I can write the external voltage as the sum of the voltage across these elements, right? So it will be L di by dt plus IR plus Q by C. Now, to solve this equation, let us use the phasor diagrams. Let us represent these vectors on phasor diagram. Now, let the voltage across the resistance be in this way. So, voltage across the inductor will be in this way, ahead by 90 degrees, and voltage across the capacitor will be in this way, VC, VL and VR. Okay, now let the current be I is equal to Im sin omega t plus phi. Take the current to be in this form where phi is my phase or phase difference. I don't know what it is, let's calculate it. But now the resultant of these three should be equal to my V, right? So I'll write this diagram again in this way because VL and VC are opposite, right? So they can be added, VC minus VL. Anyways, the magnitude will be decreased, of course, because they are opposite, right? And this will be my VR, voltage across the resistor. Let the resultant be this one. Okay, this will be my V. And the phase phi is nothing but the angle between V and VR. Got it? This will be my phi. Because phase difference is nothing but the angle between voltage source and current in the circuit, right? This is the voltage source and current in the circuit will be in the same direction as the voltage in this resistor, right? So this will be my phi. And what can I write from this? This resultant V is given by the resultant of VR and this magnitude VC minus VL. So I can write them as V is equal to VL plus VR plus VC. Of course, they are not added linearly, they are added vectorially. I anyways wrote the current in this form, right? So let's find the phi, but I want to find the Im, that is maximum value of the current, that is current amplitude. So for that we'll consider the magnitudes of these vectors only. So what can I write? The magnitude of resultant, that is Vm, its square will be equal to the resultant what? By Pythagoras theorem. It will be Vrm square, that is the voltage across resistor, plus the magnitude of this one Vcm actually, minus Vlm, its square. Got it? Just by Pythagoras theorem, the magnitudes are added. Now I'll write this one as Vrm can be written as Im into R, its square, plus Vcm can be written as Im into Xc, where Xc is the reactance of the capacitor, okay? And here I have Im into XL for inductor. I can square this, and finally I'll write this one as Im square R square, or I'll take Im square common from all the terms. Im square of R square plus Xc minus XL whole square. This is C. Okay. Now this is Vm square, right? So what is Im? Im will be Vm by root of R square plus Xc minus XL whole square. Observe this. Here the denominator, this term is playing the role of resistance. Actually that is called as impedance and it is denoted by Z. impedance is nothing but root of R square plus XC minus XL in a LCR circuit. XC minus XL whole square. Okay. So I got Im because Im is Vm by this impedance, right? R is known and these values can be known from the initial conditions, and Vm is also known. So I solved for the magnitude of Im. For solving the current equation, I is equal to Im sine omega t plus phi. I just need to find the phase now. Okay. And how will I find it? Observe this triangle. Observe observe this triangle. This V is the resultant of VR and VC minus VL, right? So I can write the right angle triangle here as this one. This is the right angle triangle where this will be my V and this is my VC minus VL and this is my VR. Got it? Observe this. I wrote the same right angle triangle and the angle between V and VR is phi. So this will be phi. Now let us solve it neatly. This triangle can also be written as R here because VR is nothing but current into R. And similarly here you have IC minus XC minus XL and here you have net impedance Z. So this is my phi, right? From this right angle triangle, what can I say? Tan phi is nothing but XC minus XL by R. So my phi will be XC minus XL by R and it's tan inverse. So I got my phase also, which is nothing but the tan inverse of this one. And note that if XC is greater than XL, what happens? Phi is greater than 0. That is, the phase will be positive, which means that the circuit is predominantly capacitive because in capacitive circuit we get positive phase, right? And if XC is less than XL, then your phi is going to be negative. That means that the circuit is predominantly inductive and current lags the voltage, or else in this case current leads the voltage. A resistor of 200 ohms is connected to a capacitor of 15 microfarad, which is in turn connected to uh, voltage source, AC voltage source of 220 volts. Of course, this is the RMS voltage, note that, and the frequency is given as 50 Hertz. Now I want to calculate the current in this circuit. Okay, the net impedance will be root of R square, that is 200 square, plus what? Here you don't have any inductor, right? So anyways, XC you have to take it, which will be 1 by omega C. Now I have to calculate omega. What is omega? 2 pi and frequency, 2 pi frequency. So my omega is 100 pi. So 200 square plus 1 by omega is 100 pi and capacitance is given as 15 into 10 power minus 6 and this square, and calculate it. It's just a game of numbers. You will get the Z to be 291.5 ohms. How to calculate the current? Current is nothing but Vrms by net impedance. That gives you IRMS. So it is 220 by this 291.5, which is nothing but 0.755 amperes. And note that this is the RMS current. Okay. Next part, I want to calculate the voltage across the resistor and capacitor as well. So voltage across capacitor is nothing but current RMS into the reactance due to the capacitor XC. That will give you the RMS voltage across this capacitor. So 0.755 into XC is what? Use that formula 1 by omega C and you will get it to be 160.3 volts. And similarly, voltage across the resistor R will be IRMS into the resistance, that is 200 ohms, and you will get it to be 151 volts. Observe one thing. My resultant of VC and VR should give me the external voltage, right? So if I had 151 and 160.3, I'll get 311 something. Okay, 311.3. So this is absurd, right? Because you are multiplying here with RMS current only. So these values must be the RMS voltages. And when you add them, you are getting something more than the RMS voltage of the source, that is 220. The thing is, you have VR and VC, but you can't add them linearly because they are out of phase. VR will be something like this, and capacitance, the voltage due to capacitor, will be 90 degrees ahead of it, right? So this should be VC and this will be VR. So the net voltage due to these two will be given by the hypotenuse, and by Pythagoras theorem that's nothing but VR square plus VC square. So you have 151 square plus 160.3 square, and root of it will be 220. So here you are done. This is equal to the RMS voltage of the source. From the above calculation, we have seen that I is given by I sine omega t plus phi in RLC circuit, where phi is given by tan inverse of XC minus XL by R. Hope this is fine. And what about power? Instantaneous power, as usual, is V into I, and I can write V as Vm sine omega t. It is the source voltage, and I found out the I to be Im sine omega t plus phi, right? So again, by same procedure, Vm and Im I have here, and sine omega t into sine omega t plus phi can be written as sine A sine B can be written as cos A minus B, that is cos phi, minus cos A plus B, that is cos 2 omega t plus phi. And I have pi 2 here. This is a mathematical identity. Okay, this is Vm Im by 2 into cos phi minus cos 2 omega t plus phi, right? This is the instantaneous power. What about the average power? For calculating average power, I have to take the average of these terms, right? Anyway, Vm and Im is constant, and inside phi is not changing with time, so this is also constant. I only have to take the average of this term. The average of cos 2 omega t plus phi is nothing but 0, because cos also varies from minus 1 to 1, right? So my final power, average power, is Im Vm by 2 cos phi. I can write the same thing as Im by root 2 Vm by root 2 cos phi. Why am I writing like this? Because I want to write in terms of IRMS and VRMS. Okay, this is the average power, and the same thing can be written also as IRMS square into impedance into cos phi. Both are the same, right? The power depends on phase, right? This term cos phi is known as power factor. Note that is important. And one more thing, Z cos theta is what? In this right angle triangle, we had phi here, Z here, R here, and XC minus XL, right? So Z cos phi is nothing but R. Are you getting me? So average power can also be written as IRMS square into R. That's it. Where R is the simple resistance in that LCR circuit. What does this mean? It means that the energy dissipated is dissipated only through the resistor, not through inductor or capacitor. So if phi is 0, cos phi will be 1, and hence the power will be maximum. That is for a pure resistive circuit. For a purely inductive or purely capacitive circuit, the phi will be either plus pi by 2 or minus pi by 2. So cos phi will be 0 there, and hence the power will be 0, as we have seen in the earlier videos. Hope everything is clear till now. Keep watching.